Hello, we are going to do a problem involving pulse in beats per minute, given that pulse is normally distributed. So, reading our prompts, according to WebMD, a normal resting pulse in beats per minute for adults and children over 11 years old is between 60 and 100. We are to suppose that these pulse rates are approximately normally distributed with a mean of 79 and a standard deviation of 12. We are asked what percent of adults and children over 11 years old have a normal pulse rate. So we have some keywords within this problem that are going to help us be able to solve this problem. The first of which is that it is normally distributed. And so based on that, we are going to draw ourselves a picture and go from there. So we know that normally distributed means that our data follows a bell-shaped curve. So we do our best to approximate a bell-shaped curve, and we draw the horizontal axis for our bell-shaped curve. My curve should be symmetrical. You can see mine's not exactly. In the middle of that is where the mean is, and we are told that the mean here is 79. So we use the Greek letter mu for mean, and it is 79. We know that the normal curve is divided up by standard deviations, and that we're concerned about the first three standard deviations on each side. So 1 standard deviation, 2, and again these are not 10, 20, 30. We're using the Greek letter here to represent standard deviation. These are above the mean, so these are all positive. We again divide into thirds below the mean, and these are -1, -2, and -3 standard deviations below the mean. Now, this example, we're going to use as many shortcuts as we can. So even though we're told that the standard deviation up here is 12, I am not going to take the time to add 12 and subtract 12 to figure out all the different pulse rates. But I'm going to go directly into my problem. In my problem, it asks me what percent have a normal pulse, and normal is defined up here at the beginning as between 60 and 100. So those are the two values that I care about. So in order to use the normal curve, I have to use the z-score formula. So that is to take x, our value, minus the mean, divide by the standard deviation. So finding the z-score, I'll do 60 first, so 60 minus the mean of 79 divided by 12. Put that on my calculator, and I have a z-score of -1.6. And that makes sense to me because I can tell that 60 is below the mean, so it makes sense that it's negative. So I'll do 100 as well. So z equals 100 minus the mean of 79 divided by the standard deviation of 12. Put that on my calculator, and I get z-score 1.8. And again, that makes sense to me because a pulse of 100 is definitely above the mean, so getting a positive value makes a lot of sense. So the next thing I want to do is to put these on my picture. So in order to do that, I'm going to switch pen colors here. And -1.6 would be between -1 and -2, so about here. This would be the pulse of 60, and this would be the z-score of -1.6. And then +1.8, so that would be between 1 and 2, a little closer to 2, about here. And this would be a pulse of 100, z-score of +1.8. It's important to keep in mind when I'm finding z-score, the label on these are standard deviation. That's how I'm able to find those spots here on the axis, which is labeled in standard deviations. When I look at the context of my problem, I want to know the percent that's in between here because it asks me normal, and we understand normal to be anywhere from 60 up to 100. So the next thing I have to do is figure out what percents correspond with these, and I do that by looking at my z-score percent table. So my first z-score was -1.6, so right in here. And the percent below that is 5.48. And my other z-score was positive 1.8, and we just used these interchangeably because of the symmetry. So above that is 3.59. So going back to label my picture a bit. There we go. So negative 1.6, when I looked that up, I got 5.48%. And we said that that was the area below. So that is this space here that's not shaded is 5.48%. And when we looked up 1.8, we had z-score of 3.59. And because of the symmetry, that is above, so that is this section in here, which is 3.59%. So then we want to think through, well, I have been asked about the shaded. So the whole thing is 100%, so I can take 100%. I don't want the ones below 60, so I'll subtract out the 5.48. And I don't want the ones above 100, so I'll subtract out the 3.59. Do all that math on my calculator, and I get 90.93% is going to be the percent of people that fall into the normal range. So we had talked about with the empirical rule that from -2 to +2 standard deviations would be 95%. And so this range did not go quite that high or quite that low, but represents about 90, almost 91% of the population.